So now we have RISC arithmetic instruction. Okay, arithmetic means you already know. So it's all addition, subtraction, all those things. Okay, so you can do addition, so you can do subtraction, so we can also do multiplication. Okay, so these are few examples of arithmetic instruction. Okay, so there is one example where you have y, z, you add y and z and you put it into x. Okay, so these are all registers actually. Okay, so this is one register, this is also one register. Finally you are adding the contents of the register and you are putting into one different register. Okay, so now the format, okay, the instruction format for this one, it is going to be something like this. So you have opcode, you have rd. Okay, rd means register destination. Okay, rd means register destination. Okay, actually rs1 and rs2, that means you have two source registers, one is rs1 and other one is rs2. Okay, so these are register source. So you take two sources, mean like you take the register contents of two registers. Okay, you add them, then you put it into rd, destination register. Okay, so that is the meaning here. Okay, op is nothing but identifier. Okay, it represents operation. Okay, OP represents operation. Okay, either it can be addition, subtraction, multiplication. So this is already done. Okay, so this is destination register where the final result will be stored. Okay, so this is going to store the final result. Okay, and you have rs1. rs1 is the first source register, it's going to store the value of x, and rs2 is the second source register, it's going to store y. Now the meaning is you add y and z and you put it in x. Okay, now did you understand the meaning? Yeah. Okay, so now coming to compound instructions. Okay, compound in the sense, previously there was only okay, so now you have compound instructions. Compound instructions in the sense, in the previous one you had only one addition, right? So here if you see, you have only one addition. Okay, that is just x plus y, right? But when you come down to this compound instruction, actually here it is different. Actually you have two additions, okay, and you have one subtraction. So if you have many operations in a single instruction, so that is called compound instruction. Okay, if you have many operations, okay, in a single instruction. Okay, so that is called what is that? That is called this compound instructions. Okay, so now we'll see how exactly this is going to happen. Okay, actually first what will happen? First you will take I, Y, then you will add and you will put it in one register. Then you take G, H, then you will add and then you will put it in one register. Then finally you are going to use subtraction. That means first you do one add. Okay, so this is going to have, what is that? So this is going to have G, H. Okay, so this will give us G plus H. So G plus H will be stored in X5. Okay, and second addition, so this is going to have x21 is going to have I, this is going to have j. Okay, so finally I plus j will be added and it will be stored in x6. Okay, so now you have x19. Okay, so x19 is nothing but so this is x5 minus x6, right? So that is nothing but g plus h, okay, minus I plus j is equal to, what is that? It is stored in x90. Okay, so now finally this is the destination register here. Okay, did you understand?
Yes.
Yeah. Okay, so next one, immediate operands. Okay, so now actually in the previous case, if you see, these are all registers, right? I already told we have how many registers? We have registers starting from x0 to x31. Okay, so these registers will store values, right? So now whatever we are dealing with, these are register based operations, right? These are register based actually. Okay, but whatever we are going to see next, they are not register based. Actually they are immediate operands. Okay, immediate operands means, okay, so you have x, you take x, okay, and whatever it's there in x, you add it with the 7. Actually 7 is number, right? This is a number. Okay, so this number is said to be immediate operand. Now did you understand? Immediate operand means it's a number. Generally it's a number. Okay, so commonly if you want to add a fixed constant to a number, okay, fixed constant to a number or fixed number to this register, so there you are going to use immediate operands. Okay, so now how do we use this immediate? Is actually this is done with the help of add I. Okay, there in the previous instruction it was just add, right? It was just add. So now here it is going to be add. Okay, add I. I means immediate. I stands for immediate. Okay, so you take the source register, you add it with the immediate register and you put it in the destination register. So here source is also what? Here source is also x. Okay, immediate is 7. So finally this will be x. That means x is equal to x plus 7. Did you understand the meaning?
Yes.
Yeah, okay. So now that what you have to remember, immediate means there is some number. Okay, there is some constant. Okay, so now you see here, why do we need to do this? Is actually it will avoid unnecessary load instruction. So generally what will happen, so I will maybe take this one. Okay, so you have add. Okay, so you have add R1. Okay, so R2 plus R3. Okay, so can you tell me the meaning, expression of this instruction? Expression.
Yeah. Like this, you're taking R2, R3 and adding it and storing the value in R1.
Yeah, so that means this is R1 is equal to R2 plus R3, right? Actually what will happen, this is not actually, even though we show it in a single instruction, this is not going to happen in a single cycle. Okay, what will happen, first you will try to get the value of R2. Okay, so R2 will be stored somewhere in memory, right? Actually it will be in the memory, somewhere it will be in the memory. Okay, so this value will be taken and it will be put it into R2, and again R3 will be again somewhere from the memory. Okay, so you have to load from memory. Okay, so load from memory, so that is called load. Okay, so load register, load from memory to register. So generally it is given as LDR, load from memory to register. Okay, load from memory to register. Okay, so now you see here what I'm trying to tell here, if you are using registers, okay, without immediate, what is going to happen, every time you have to load R2, load R3, right? So if you have an immediate value, okay, you know that you have some immediate value, so you can reduce one load instruction, right? You can reduce this load instruction so that it will save one cycle. Okay, it will save computation. That's why we are going to, so if you are using immediate, so it's going to save one cycle or one operation. Okay, so that's why we go from what is that, register based operation to immediate based operation. Did you understand? Immediate means wherever you have I immediately after the operand, that is called the immediate. Okay, so now you see here, this is an immediate constant 4, you add it with x2 and you put again in x22. Okay, did you understand? So the meaning is x22